So we have our two coupled second order differential equations, one that we got from theta 1 and the other one that we got from our theta 2. Now what we want to do is replace these with four first order differential equations. Now note as well, I think in the previous page I missed out this little 2 here. I think I just did the m, so it's actually m2, just a note there. So what we're going to do is we're looking at the theta 1 dot. So theta 1 is d theta by dt, so it's the angular frequency. Now you normally write the angular frequency in terms of your omega variable, so we'll call this theta 1 dot as omega 1. So this is your angular frequency in radians per second, and theta 2 dot is your omega 2, and we can call our theta 1 minus theta 2 delta theta. And it's just a reminder, the angular frequency is written as 2 pi f, or equivalently 2 pi upon t. So you'll have seen that before in previous videos, or if you've done a little bit of engineering or physics. So what we want to do is replace the terms up here with these terms here and simplify this down a little bit. So we can replace the theta 1 double dot here simply with the omega 1 dot, because the omega 1 is the rate of change of this angle with respect to time, but it's also been differentiated once more, so we're going to have to differentiate this once more in order to make this omega 1 dot will equal the theta 1 double dot. And if you notice here as well that there's an L1 in this term, there's an L1 in this term here, and an L1 in this term, and an L1 here, and the whole equation here is equal to 0, so it means we can cancel out these L1s. Okay, so down here we're going to be left with just the single L1, because this is L1 squared, so now we'll have m1 plus m2 times the L1 omega 1 dot, so that's straightforward enough. The second one here is going to be our m2, and our L1 cancels out, so we're just left with L2 omega 2 dot and the cos of delta theta. We're going to have the term here, so it's going to be our m2 and our L2, the L1 cancels, and we'll just be left with our omega 2 squared. Okay, and the sine theta 1 minus theta 2 is just going to be our sine delta theta. And the final term here will just be left with our g, m1 plus m2, g sine theta 1, and that is all equal to 0. So take your time and read over that and ensure you understand how we got from this line here to this line here using these terms here as a substituting in. So the second one here, we're going to get the m2L2, and we'll have omega 2 dot for this one, m2L1 omega 1 dot times cos of delta theta. This one here is going to give us our minus m2L1 omega 1 squared sine delta theta, and this one here is going to give us our m2g theta 2, and that is equal to 0. So again, take your time and make sure you understand how I got from this line to this line using these substitutions. So let's take these two equations here and let's simplify them again. And you can note here we've now got two first order differential equations which are coupled. By coupled we mean that we have like terms in each of them. So let's see that on the next page. So we have our two first order equations here. So let's rewrite this as two simultaneous equations using these substitutions here. So if we let a equal m1 plus m2L1, so that's this term here, we'll be left with the omega 1 dot, so that's this first part of the simultaneous equation. And if we let b equal m2L2 cos delta theta, that's m2L2 cos delta theta, then we'll have the omega 2 dot, so that will be b times omega 2 dot. Now if we take what's left over here and we move it over to the right hand side, then we'll have the minus of this and the minus of that, and we can call that term here term E. And then we look at the term down here, so term C is going to be M2L1 cos delta theta. So that's the M2L1 cos delta theta. So what's left over is our omega 1 dot. So that's the C times the omega 1 dot. And then the D term is M2L2. So the M2L2 term is this term here, and it's going to be left with the omega 2 dot. So we're going to have the d omega 2 dot, and we take what's left in this line here and we move it over to the right hand side, and we call that our value f. So this is our value f here. So finally we've got this little simultaneous equation here. So let's continue with this on the next page. So we have our simultaneous equations here. The omega 1 dot and omega 2 dot are on the left hand side, and on the right hand side within the E and the F we've got our omega 1 and omega 2. So we want to solve these simultaneous equations for omega 1 dot and omega 2 dot. So this is just a bit of algebra. I will go ahead and I'll solve it for omega 1 dot, and then you can go ahead and you can work through the algebra and see that you get the solution here that I get for the omega 2 dot. So for the omega 1 dot, what we'll do is we'll rewrite the bottom equation here in terms of omega 2 dot, and then we'll substitute that value in for the omega 2 dot here, and then we'll solve for the omega 1. So we'll do that now. So the omega 2 dot is going to equal f minus the c omega 1 dot upon the d. We then substitute this into the first equation, so we'll get the a omega 1 dot plus, and it will be b times the omega 2, which is this one, which is f minus c omega 1 dot upon d, and that whole thing is equal to a value of e. So we'll multiply out. When you multiply out you get this here, so we're just multiplying out the brackets, and then we'll just rearrange this, and it's rearranged in this form here. So it's just exactly the same. I'll just move this one over to this side and that to that side. And we'll take out the common factor of omega 1 dot, and that's going to give us our a minus bc upon d, and then we'll take this term here over the other side, so we'll get e minus bf upon d. So therefore we can say omega 1 dot, we can take this whole term down underneath, so we'll get this term divided by that term, and then we can take the common factor here of d, so we'll get our ed minus bf, and with the common factor here of d you'll get ad minus bc upon d. And when you divide through it with a fraction, you multiply by the reciprocal, so we multiply out with the reciprocal, the d's cancel out, and we'll get our omega 1 dot is equal to ed minus bf upon ad minus bc. Okay, so that's one that we're looking for. Now the other one, omega 2 dot, is equal to af minus ce upon ad minus bc. So that's us almost there. What we'll do is we'll gather all of the equations together that we have on the next slide. So this is us gathered all of our equations together. We started off with 2 second order differential equations. We've now got that down to 4 first order equations, and these are our 4 first order equations here. So we've got our omega 1 is equal to theta 1 dot, omega 2 is equal to theta 2 dot, we've got a omega 1 dot plus b omega 2 dot is equal to e, and we've got our c omega 1 dot plus d omega 2 dot is equal to f. And we can say that our omega 1 dot is equal to ed minus bf upon ad minus bc, and omega 2 dot is af minus ce upon ad minus bc, and these are the values of a, b, c, d, e and f. So we can take all of these now, and we'll go and we'll put them in first of all to MATLAB, and we'll simulate the double pendulum on MATLAB. So well done if you got this far and you've got to these equations. This is a real milestone for us. Everything else now is a bit of fun, and getting to see the actual pendulum operating. So thank you for listening. I'll get you in the next video. Goodbye.